Well, let's have a look at some graphs of rational functions. This is a fascinating area and I'm sure you'll find it interesting, and once you grasp it you'll really feel confident about this. So let's make it easy for you. We have two categories of functions for which we have to be able to competently draw the graphs of. They are, firstly, y equals x to the n1 plus x to the minus n2, where n1 and n2 can be either 1 or 2, and I'll show you what that looks like in a moment. And we also have to be able to do reciprocal quadratics, okay? Now here's category 1. What we've got here is a 2 by 2 table to show you what I'm talking about. So you can see that I've got n1 can be 1 or 2, and n2 can be 1 or 2, okay? Now, okay, so there's the first the first outworking of that strange looking formula up there. So I've got basically n1 is 1, so that's x to the 1, and n2 is 1, so that's plus x to the minus 1, or 1 over x. And that looks like, I've got a little mini postage stamp version of what that's going to look like, and then we'll go into more detail in subsequent screens. Oh, alright, I'm going to show you the postcards in a minute. That's x to the 2 plus x to the minus 1, okay? This one here is x to the 1 plus x to the minus 2. This one here is x to the 2 plus x to the minus 2, alright? We have to be able to draw the graphs of all those, okay? It's a snap, I'm telling you, so don't get worried, it's fine. That's a little postage stamp of what the first one looks like. There's the postage stamp of what that one looks like. And here's our third postage stamp. Aren't they interesting, exotic looking shapes? And there's the postage stamp of the bottom right hand side one. Okay, now if we go over the screen, I'm going to show you what they look like. First of all, we're going to do y equals x plus 1 over x. Alright, now there is x, right? And there is 1 over x. So guys and gals, what we've got to do is basically add the ordinates. We're addition of ordinates. So you've got to pick strategic x values and then add up the two individual y values that belong to them on that red and black graph. Now I use what I call clue points. There's if I pick this value of x here, for example, where these two graphs intersect, then you're basically adding up the red y value from there up to there, and you're adding up the black y value from there to there, and they happen to be both the same. So if you add up the red and the black vertical lines, if you like, from the x-axis up to that intersection point, you'll get exactly the added up addition of ordinate value would be exactly double what this y value is. Do you see what I'm saying? Same thing over here. It would be double that, which gets you to round about there. Now that's a clue point. Then what I do is I look at the relative influence of each graph to the left and to the right of those clue points. For example, here you see that the black graph is zooming off to infinity and the red graph is kind of fizzling out with a whimper down towards the origin, right? So this one is going to have more influence on the combined y value, the added ordinates for any x value between, say, 0 and 1, right? So if you pick an x value, say about x is a half, then what you're going to get is the combined y value will be whatever the black value is, because it has the most influence, plus a little bit added on to account for the small contribution that the red curve makes. If you know what I'm trying to say, I hope you do. Over here, for example, though, the other extreme is happening where the red graph is having far more influence. It's got far more y value than what the black graph does. So say for this value of x here, 1, 2, 3, 4, 5, x is 5, you'd expect the y value to be right up here to the red plus a little bit to account for that little small contribution there that the black is giving you above the x-axis, right? And you keep doing that. You keep doing that for strategic points. Now, what I want to know is, do you have an idea of what that combined graph of y equals x plus 1 over x would look like? Have you locked something in? Because pause the video if you haven't and work it out, because I need you to get this. I really do need you to get this, right? You've got to be a bit of a detective, and a lot of students have a great deal of trouble working out what the addition of ordinates would look like. It actually mystifies me as to why they do, but for some reason they really do. So I need to allow for the fact that you might be having a bit of trouble as well. So pause the video, come back when you're ready and I'll show you, alright? You right? Okay, you're back. Alright, here we go. You ready? Ready on the count of 3. 1, 2, 3. Did you get that? Or something like that, right? Good, you did. Well now, when you do these graphs, you have to do all intercepts, x and y intercepts, and you have to do all asymptotes as well. That's what the graph looks like without those individual components. Okay. Now, what are the asymptotes? Let's go back one. What are the asymptotes? You have to draw that in. This is an asymptote. Y equals x is an asymptote, and this one here. Now, what's the asymptote over here? Is it the black graph because the blue graph is approaching the black graph? Well, it actually isn't, guys, because the black graph in and of itself is approaching this vertical axis, the y-axis, or where x equals 0. So you've got to mark that in. If you sketch this graph, you've got to the buck stops here at this vertical line. That's what both of them are approaching, right, as an asymptote. So x equals 0, you'd have to write that in. And you'd also have to write in the asymptote here, y equals x. All right. Now let's just move on to forwards to where we were, and we'll do the next one. Okay. Good. Now this is x squared plus 1 over x. Now let's do the same process as we did in the previous screen. There's x squared. Okay. Now let's put in 1 over x. Well, how are we going to work this out? Well, come on, look. I'll tell you what I would do as clue points, right? This is going to be a clue point. The combined value of y1 plus y2, if you like, from those two contributing black and red graphs would be exactly double that point. To the left of that point, this one has more influence than the red one, and to the right of that point, this red one has more influence in terms of it has more y to contribute than the black one. Do you know what I mean? Yes. So I'm hoping that you're getting a bit of a feeling for what the combined graph's going to do in there. Now over this side, I would use a clue point here. I'd pick a point where the red value is about as far above the x-axis as the black value is below it. So the red value is positive y, the black value would be negative y, and if they're equal and opposite and equal in value, in magnitude, then the net addition of them would give you a 0 point. Do you get that? Good. Now, to the left of that point, the red graph takes off and has more influence than the black in terms of its contributing y amount, and to the right of that point, the black one takes over. Right? So you get the idea. Are you getting it now? You ready? All right. Pause me or go on the count of 3. 1, 2, 3. Fills us with glee. Did you get something like that? Now, of course, you'd have to work out the x-intercept here. Looks like it's x is minus 1. You'd have to put that in, and please use coordinate points if you can, because that's usually what they want. What else do we have to do here? Oh, you have to put the asymptotes in. So there's an asymptote here of y equals x squared. Okay, it's approaching that graph, and in here it's approaching, remember, not the black graph, because the black graph is already approaching in and of itself this y-axis where x equals 0. So you'd have to put that asymptote in as well, x equals 0. Okay, and here's what it looks like without the contributing graphs, right? Weird looking beast, I'd have to say. Wouldn't you agree? But nevertheless beautiful. Right, let's go on. Y equals x plus 1 over x squared now. Good heavens above, where is all this going? No, it's going into very great and deep understanding. There's x. Now we're going to do 1 over x squared. Ooh. Okay, now, right, are you starting to get the idea of how to do this? Well, here we go. Look, clue point here. Double this value. The yellow graph has more influence over this side because it has more y value to contribute. The green graph has more influence over this side of that doubled point where x is 1 because it has more y value to contribute than the yellow graph. So it's basically going to, I would say, look, it's going to do this. It's going to come zooming down here, following the profile of the yellow graph, but just a little bit more to allow for that contribution of the green. There will be a turning point here, somewhere around here. Not necessarily on exactly double that point, by the way. Somewhere around here, and then the green value is going to start hugging the green value, but a little bit more to allow for the yellow graph's contribution up there. Yeah? Now over here, there's going to be an equal and opposite effect. Like the yellow is got a, see that's got a positive Y value, the green's about the same but negative, so that's going to get you a net 0 point there. The green graph starts to take over influence here, down here, but a little bit more to allow for the tiny little contribution that the yellow graph's making. And say, beyond this point, which one takes over? The yellow graph, doesn't it? It starts to go up there, but it's pulled down a little bit by the contribution of this negative contribution of this green graph, which gets less and less and less as you approach the y-axis. So, have you got it? Okay, on the count of 3, ready, set, go. There you go. See? Look, it's easy as. Now let's have a look without all that green and yellow scaffolding. A very strange beastie, isn't it? It actually looks better with the scaffolding, I think, because you can sort of see where it's come from. Right, next one. X squared plus 1 over x squared. Well, this is the fourth of 4. Okay, now let's do this. There's your x squared. Now we're going to do the 1 over x squared. Gracious me. Now, okay, now pause the video and you do it. I'm not going to tell you this time. Are you ready? Pause. Alright, you back? Have you got something? Well, on the count of 3, 1, 2, 3. There you go. Look at that. Now, without the scaffolding, there. Yeah? It's better with the scaffolding, isn't it? Because you can sort of get to know what's going on. Now, the second thing we're going to do here are the reciprocal quadratics. Okay, that means quadratics on the denominator. These are very, very interesting little creatures, as you will see when I show you a few. Now, properties of reciprocal functions. I thought I'd just go over this again. Reciprocal functions are really easy to work out, but you must bear in mind the following guidelines to make them easy. When a function is positive, the reciprocal will be positive. Elementary, my dear Watson. When a function is negative, yes, the reciprocal will be negative. Yes. When a function is 0, the reciprocal will be undefined because you'll have 1 or something over 0, right? Can't do that. That causes mathematical mayhem. When the function is very large, the reciprocal will be very small, won't it? Of course, something over very large is very small. And when the function is very small, the reciprocal will be very large because something over very small is very large. And of course, if the function itself is plus or minus 1, well then the reciprocal will be also plus or minus 1 because 1 over 1 is 1 and 1 over minus 1 is minus 1. Do you get that? Excellent. Now, to sketch the reciprocal quadratic, what have I written there? Yes, you draw the original quadratic first, and then you use the above guidelines to create, conceptualise and draw the reciprocal, okay? Now, what do we got here? Oh yes, I'm going to show you, this is a a UFO landing, but this UFO is x squared plus 4, and what I'm going to do is I'm going to draw it. I'm going to actually, this is going to start coming down, coming in for a landing to Mother Earth, and then it's going to go down under the Earth a bit, and we're going to draw the reciprocal as well. There's the reciprocal. Look at that. Now, first of all, does that make sense to you? Well, let's see. This is the minimum value of the function, so therefore 1 over the minimum value of the function has to be the maximum value of the reciprocal, because the reciprocal is the fraction version. For example, if this was 4, then this would have to be 1 over 4, which would be a quarter. Whereas if this was like 8 or 10, this value would have to be 1 over 10, which is much less than a quarter. Are you starting to get me now? Alright, now you watch this. This is really, really interesting. This is the trend is your friend. Have a look at the trend, okay? And here we go. Next one, we're going to move this UFO, this spaceship, down a little bit, okay? And you watch what happens to the purple graph. The purple graph is what I'm really interested in because that's the reciprocal quadratic, yeah? Okay, did you notice any change? Here we go again. Ooh, okay, here we go again. Ah, see what's happening to the hump in the pink graph? Look, here we go again. The hump is starting to rise because this is getting less, therefore 1 over less is more, isn't it? Yes. Now, when we get down to 1, what's going to happen? When we get down to y is 1, what's going to happen? You ready? Here we go. Yes, they're going to intersect because 1 over 1 is 1. Isn't that right? Now, can you make a prediction about what might happen when this red graph actually touches Mother Earth here on the x-axis? What do you think is going to happen? Well, yes, all right then. Well, we'll see. There, look at that. Now this is a half, therefore this is 2. See, it all makes perfect sense, doesn't it? Now here we go for the cataclysmic moment. You ready for this? We're going to hit Mother Earth with the red function. Oh, look at that. Look, it's a geyser, or whatever you like. You see, because this thing here is 0, and of course you can't do 1 over 0. So this guy flips out and goes undefined up into the ethereal, amazing cyberspace of intergalactic nothingness. Boy, did I just say that? Okay, so there it goes. Now we're going to go under. Terra firma now, under. So what do you think is going to happen to the pink graph? Come on, think about it. What's going to happen? Well, you ready? There she be. Okay, because look, when the mother ship is negative, so is the reciprocal negative, isn't it? Of course it is, right? Now can you see those two, where the asymptotes would be? The asymptotes for the reciprocal are going to be where the mothership hits the x-axis and is 0, because you can't divide by 0 for the reciprocal, yeah? It's interesting, isn't it? Okay, now I've gone down to -1 here on the mothership, and this thing, the reciprocal, of course, is -1 as well. So that's all right. Now I'm going to go further down just to show you. Good heavens, look at that. So now we've gone down to -2, and this thing is -1/2, because 1 over -2 is -1/2. I think you get the deal, don't you? All right, so I think that taught me a huge amount when I actually did that for myself, yeah? I think that's the end of it. Oh, no, one more, okay? One more. That's gone down to 3 now, and that's -1/3, okay? All right, some example questions for you. Here we go. Sketch the graph of y equals x squared plus 1 over x, where x can't equal 0. Well, now look, when you look at this, you think, good grief, what am I supposed to do with this? Fear not, my child. It's very easy. There's a little rule that you follow, and that is that when the degree of the numerator, I mean the highest power of x, when the degree of the numerator, in this case 2, is greater than or equal to the degree of the denominator, in this case 1, when it's greater than or equal to the degree of the denominator, you must divide the denominator into the numerator to make any sense out of it for graph drawing purposes. Now, hence, look what happens. Now look, that's an altogether order of magnitude easier to see what we're supposed to do with it, right? Because we just did it on a few screens ago, didn't we, right? So you divide this term by x and this term by x and present them as separate terms, and, well, it becomes easy, doesn't it? Yeah? Right, so there's x, there's 1 over x, and there's the combined shape. You know, we've just done it. I think that was the first example we did. So, alright, so asymptotes are x equals 0, that's the y-axis. Remember, the black one also approaches the y-axis, so that's what the asymptote is. And y equals x is the other one, right? And there are no x or y intercepts, yeah? NB, oh, what have I written here? Oh, yes. Please watch asymptotic behaviour when you are sketching graphs. Look, this is a train wreck, this area. You must make sure that the graph must approach the asymptote as appropriate, not swing away from it again after approaching. So look, if I give you this here, right, that looks pretty good to me, yeah? Because this black graph is approaching this asymptote, it's approaching this asymptote, approaching. Now what you don't do is that. Now where is that wrong? It's wrong there. Look, it's bending away from the x-axis in this position and this position, and you are going to burn your marks. You don't do that. Please be careful. And please take a small ruler into the exam to make sure that you get that bit right. You can do it with a ruler to make sure it actually approaches. That's the only surefire way that I know of doing it. You know, a small investment in a small ruler can save you some marks, so why wouldn't you do it? Exactly. There's the finished product, ladies and gentlemen. So here's my asymptote y equals x. Here's my asymptote x equals 0. That's my 1 over x, and this is my combined graph here. Yeah? Alright, you get the idea, don't you? NB, oh, here's another NB. Goodness, I'm pretty heavy on the NBs today. Oh, what I said there was, please draw single line graphs. Single line graphs. Not multi-line, feathered style, airbrushed style graphs. This loses marks. The examiners hate it. Now, if you've got your smarts about you, you will draw your graph in pencil. If you want to mark over it in pen later when you've got it done, that's all right. Make sure the pencil's not too light, that you can see it. But look, if you draw in pencil on a defined grid on an exam, then what happens if you drew it in pen and then you needed to change it? You end up with a huge mess. So you draw it in pencil and then you can rub out if you need to, all right? That's the thing. Please do that, and don't do graphs in pen, but do make sure that they are single line, they do approach the asymptotes, and they are heavy enough for the examiner to see, all right? Apart from all the other things like marking in all your x and y intercepts and your asymptotes, and please do asymptotes or in dotted lines is better than hard lines, because it just makes it easier to see that that they're not the actual graph that you're drawing. They're just an asymptote, right? All right, you get the deal. What's this? Sketch the graph of, okay, another incomprehensible mess, but once you divide by x squared, because the degree of this is 4, the degree of this is 2, hence we must divide. So what happens now? We're just going to get y equals x squared plus 1 over x squared. Oh, yes, yes, yes. The degree of the numerator is greater than the degree of the denominator, so we're going to divide the denominator into the numerator, and we get y equals x squared plus 1 over x squared. Well, we just did that a few screens ago too. You see how easy it is now to see? So much easier. There's your x squared, there's your 1 over x squared, and come on, you know what it's going to look like, don't you? Well, here it comes. There she be. That's the shape, right? It's a bit rough, but look, you get the idea. Right, so what have we got here? Asymptotes are x is naught, not 1 over x squared. Don't make that mistake. This one also approaches x is naught, or the y-axis, this black one. And y equals x squared, yes, it approaches y equals x squared over here and over here. And have we got any intercepts? No. No intercepts, no, no, no. So let's go and do the graph now. There it is, okay? That's the actual official thing that I've got on my iPad. So there's 1 over x squared, this one, and there, this purple one, or the pinky one, is x squared, and this red one here is x squared plus 1 over x squared, yeah? Okay? Is everything good? Now, I've marked in my asymptotes, haven't I, like a good boy? You must do that too. You must do that. So I've already got this x squared marked in here, so that's good enough for an asymptote. In real life, you would do these as dotted ones, because, you know, it's not the main event. This one here, and over here, this lobe of it are the main graph that you're actually drawing. Are you getting me? Good show. Now it looks like I've got another one. Good gracious. Now this is y equals x cubed plus 1 over x. Look, degree 3... Degree 1, what do? Yes, you know, you divide. So therefore, y equals x squared plus 1 over x. Well, that's another one that we just did. You see? How easy. That one. Now, this is a weirdo looking one. Come on, if you got it, you work it out. I can see it. Can you see? Because I've done a few more of these than you, so you probably take a bit longer to see. Have you worked it out? Well, there she be, right? Something like that. Now this time it looks like we do have an x-intercept, don't we? We're expecting one, but we're not expecting a y-intercept at all, are we? No, no, no. The asymptotes are x equals naught, again the y-axis, and y equals x squared, yes. There is an x-intercept, but there's no y-intercept, yeah? So we solve for the x-intercept y is naught, we get that, don't we? Do we? Yes, we do. Yeah, you can actually use this version for that. Make that naught, multiply both sides by x, therefore you get that, therefore you get x cubed minus 1, therefore you get x is minus 1, okay? And that'll be minus 1 and naught, that'll be your x-intercept. Very nice. Here it comes. Now, have I done everything right? I've got my x-intercept in, I've got this graph here happening, 1 over x, and I've got this graph, what am I trying to do? This is the x squared graph, I've got that in, there's my combined graph. Now that's an asymptote, and which other one is an asymptote? The y-axis, yeah? X is 0, and this one here, y equals x squared. Yeah, everything good? Okay, let's move on. Now I think I've got a, I've got a reciprocal quadratic for you now. Funny about that. Here we go. Now, this is a different kettle of fish. Now, what I do here, yes, it is indeed. Thank you, Mr. Computer. So what we first understand and sketch the graph of, say, g of x, I'll call it, x squared minus 5x, and then basically we deduce the reciprocal function from that. So if you've got g of x equals x squared minus 5x, which is that, which will have x-intercepts where x is 0 and x is 5, that's what the graph would look like. Would you agree with that? Yes, you would. Okay. Well now, for the reciprocal, y is going to be undefined when x is 0 and x is 5, because you can't be having 1 over 0. The y value of this is 0 where x is 0, and the y value of this is 0 where x is 5. So where you have x is 0 and x is 5, you're going to have asymptotes for the reciprocal, the 0 x-axis intercept points, right? So that's the first thing. Also, when y is positive, g of x, the denominator this is g of x, the denominator bit is going to be positive, and where y is negative, the g of x is going to be negative, and so on and so on and so on and so on. You get the whole thing, don't you? When g of x is large, y is going to be small, and where g of x is small, y is going to be large. Yes, yes, yes. When g of x is plus or minus 1, y will be plus or minus 1. You knew all that because I summarised it a few screens ago, but I just thought I'd really try and bring the point home to you. Now, what I've done here is I've actually worked out the vertex of g of x, right, this, because that allows me to get a pinpoint on the vertex of the reciprocal. So I know that the vertex is going to be halfway between x is 0 and x is 5. That'll be 5 over 2. So if I plug and play that into g of x, you'll get the y value of the vertex, which looks like minus 6 1/4. Yes. Now, therefore, if the vertex of this black graph up here, the g of x graph, is going to be minus 25 over 4, then the vertex, the local max vertex of the reciprocal will be minus 4 over 25. That's what it'll be. Yeah, that's the vertex of that. Therefore, the vertex of the actual graph we're trying to draw here is going to be minus 4 over 25, right? I'm doing that for sort of proportions to sort of work things out so that they look right on the graph, yeah? There, look at that. Now, did you get that? You see how easy it is to do that? This blue shape, once you've got the black one nailed, okay? That's what I always do. But if you were going to leave this black graph on here, you'd do it dotted, and you'd make sure you label the thing so that you don't confuse the examiner, and you'd put a nice big arrow on this to say that, you know, this is what we're interested in, you know, the 1 over x squared minus 5x, wouldn't you? And of course you'd label these asymptotes, x is 5, x is 0, and you don't need to actually label the vertex. You don't need to do that unless you're asked to do that. But I'd put 0, 0 here and 5, 0 here, and I'd put x equals 5, x equals 0 for my asymptote values. This one would be dotted. This one, it was just the y-axis anyway, so you wouldn't try to dot that. Okay, and of course this is another asymptote here, y equals 0 in this case, isn't it? Right, this one, the x-axis, y equals 0. So you'd be writing that as an asymptote. So there are 3 asymptotes of this blue graph, aren't there? Yes, we can see that. See the next screen for the final sketched graph of y equals 1 over x squared minus 5x. Here it comes. Very nice piece of work. Yeah, it's exactly what we predicted, isn't it? It's exactly what we predicted. So, good show. So, are you happy? I think so. And I think that's the end of the line. So, mighty fine, and we'll go and we'll have a nice cup of tea. I'm going to have an English breakfast. So, I wish you one as well. And we'll see you in the next exciting instalment. Okay? See you then.